Very good evening to all. So today we are here to learn about fraud analytics, and we are learning step by step. When I say step by step, in the day one or in the previous 1 hour, we have come across the applications of machine learning and artificial intelligence for fraud analytics. So today we are going to learn more about a machine learning standard methodology that will be followed for any process of machine learning model. So today, apart from other project management methodology, we follow CRISP MLQ, which is very efficient and it is user convenient and easy to keep track of the steps that you follow for completing this project. So upon all risk, the community with respect to machine learning have come up with a standard process model, because usually we had KDD and SEMA, which was earlier project management methodology. So that was followed. So this CRISP TM is the combination of both of these, KDD and SEMA. So as a result, machine learning as well as data science are supposed to be well organized by following some standard process model. So in general, the projects are usually conducted in ad hoc manner. So to confirm, the machine learning developers or any practitioners, the development life cycle, the machine learning development life cycle will be followed with the help of CRISP MLQ. So when I say CRISP MLQ, it is a cross industry standard process that is followed for any machine learning model. So why is this Q? It is a quality. That means it is a quality assurance methodology that has been recently proposed, where the core of the machine learning is reviewed in any ML model development process. So today we are going to understand what are the different processes that we undergo in developing any machine learning model. Irrespective of the model, we follow some procedures that we are going to understand. So the machine learning model process life cycle consists of some analytical stages, different analytical stages. Basically, we have 4 different stages of analytical stages, which is descriptive, diagnostic, analysis, predictive analysis, and prescriptive analysis. So descriptive analytics, you are describing or giving a description what had happened. And diagnostic is diagnosing what or why it happened. And predicting how it has happened. We are predicting and what you need to do in future if you get the same. So these are the different analytical stages that we follow in every models. So when we consider an example of a patient visiting a doctor, so doctor is not a god to tell what happened, what is happening inside the patient. Only upon giving a confirmation what has happened, what is happening, doctor then can diagnose and tell what could be the possibilities that has happened and give a medicine to remove that disease or disorder and confirm the patient to be safer in future. So the patient goes and describes what happened. Let it be from past 3 days, he is having a fever. He is having a headache. And he is not feeling fit, is ill, his body is body pain. So based on all these description, what the doctor is going to diagnose and can predict what could be the possibilities, how it has happened because of air, water, food infection. And it has been predicted that this is the things based on doing some tests. Upon getting some confirmation based on the test, it has been predicted and then prescription is given to the same. So it is not only with patient and doctor, even when you are doing with respect to the data analytics, you are supposed to format in the same. First, you need to understand what the data is all about. You need to describe what is the data and what you need to be. And later you need to process the data. When you process the data, you will understand few things. Based on that, insights what you get from the data need to be analyzed and predict by using some models, or I can say methods, or I can say algorithms. And after predicting, you can use that model by deploying and be safer for in future. If there is a new input for the model should respond and give an output there itself. Again, it need not to go with from the step. What is the data is all about? What is the process that you need to understand the data? How you need to understand the data? What module you need to use it? And then you need to prescribe. No, you should not. So till here, your model should be analyzing different ways of data. And in the last step, it needs to consider the different input and predict the output. So this is how every software development lifecycle follows. Even machine learning quality assurance management is also following. So when I say different stages of analytics, CRISP MLQ is also following different stages, which is in cyclic manner, or it can be a regular dependency, a development life cycle, where each step is important to proceed further and can obtain the model with some accuracy and meet the objective as per the client. So as we all aware of, before any project development, we need to understand what could be the project or business problem. So we need to sit and talk to a client or a concerned person to understand what is their requirement. For example, if you want to create or if you want to construct a building, you need to sit and talk to a designer, what we call it as constructor engineer, to design your plan as per your requirement. Why you need to sit with an engineer or a person who has this skill? Because you can plan that the bedroom, the kitchen, the hall, the other things should come in this way, come here, 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 but you need to more cautious with the measurements. The measurements is with the land, the measurements is with the wall space and the corridor and car parking or vehicle parking space, so वगैरह, etc. Let's say example, we have a 30-40 of site and we do have construct a house and you need to plot this as per your requirement and you have made a things. But when you have a particular walls, you need to also measure this space, and hence the actual plot area will come to reduce and it will not be exactly 60-40. So whenever you want to understand some business problem, you need to go with understanding the basic with the client. Now, my client is a financial organization, expert, or an owner that comes to me with the data, with the customers and their transactions using their cards. The customers are using their cards to make a transaction and need to predict which transaction is a fraud transaction, what is the objective here? Detecting the fraud transaction. Why it is to be done? To get a trust on this financial organization. The people start approaching this organization and take more and more cards from this, so that it will be more secured, safety and protective, even if there is any fraud. So every organization will approach a data analyst and inform them by providing the data to go through this and conclude saying the fraud transaction is detected, and in future how to avoid it. So the client has been clearly mentioned what is the business problem. Now, after giving data to me, the process will be developing by the process will start by the data analyst by understanding the data. So we need to understand the data, whether it is a different types, cases, or whether it is categorical, whether it is continuous, whether it is discrete, whether it is variate, whether it is multivariate. So data understanding and pre-processing will take more time than any other steps in this methodology. So after business understanding, you need to understand the data and you need to prepare the data. So prepare the data in the sense, the model will understand the data which is fed, that will be splitted as trained data and test data. 80% of the data will be used to train our model and know all the patterns, all possible patterns, and then we'll provide a model to test with the 20% of data, so that it has been already trained to understand the model, to understand the input. Hence, once it is provided, it will give you some accuracy. Let's say example, I'll give you an example. One of the transactions says 10,000 rupees. The card was not used from 2 months, and immediately it has been made a transaction of 10,000 after 2 months. So won't you think that it is unusual? For this, you need to have a confirmation from the cardholder whether the transaction is done by you or not, because the model has been detected saying that it is unusual transaction. Hence, this unusual transaction will be identified by the trained model, which informs the concerned person who is working on the model, and tells that it is unusual to contact the card holder to get a confirmation. So the model is doing 80% of the work in detecting this unusual or illegal transaction. So we can't directly say it is a fraud transaction. We can segregate that it is a legal or non-legal. When I say it is a legal or non-legal, usual or unusual, so you need to split the data and you need to understand the data. Arvind, please turn off your video. So after understanding the data, you need to build the model. So I forgot to tell that when you are doing data processing, we also say that it is a data cleaning task. So there are various process and the steps that is involved in each and every step. So that we'll see here. So business understanding, every project will follow the first step, that is understanding the business, to know the complexity, scalability, robustness, and the resource management. And it is also keep track of optimization. So everything needs to be documented. So we refer to be that as a project charter. So project charter is a document that will be signed by both the people who is giving the project and the people who is accepting the project, so that the work will be having more transparency. Later, client should not say that have already told this and that, and there should not be any amendments. So the client should not come back in adding anything in the middle, because sometimes it is cost oriented and also it is with respect to time. Since the person who is committed to do the job might have committed to the other job. So if this project is extending, then it will be having a budget issue and also the time issue. So hence everything needs to be captured and made it as a document. So the document is mutually agreement by the project sponsors, and the project who is doing it. So this is our first step. The second step is, as I told you, data preparation and data understanding. When we understand the data, the data should be feasible without any missing values, without any duplications, and it should be having some regularity for the constraints, and with all requirements. So the data needs to be cleaned before extracting, and this phase plays an important role in any of the project management under machine learning, data engineering, data science role, which is referred to be as exploratory data analysis. So I've told you 40% of the job is done here. Where the data collection, the data verification are essential in achieving the business goal. So one crucial requirement is documentation. The properties of data and data generating process should be captured. Similarly, data requirements also need to be analyzed. Either client will be provided or the person will create a source to collect the data. So this is a secondary source. Where it is time consuming. So this also needs to be mentioned in the document. So we also need to standardize the data, and we need to explore the data, and we need to prepare the data without these things. So for that, we follow different steps that will give you information that the data is like this. The data is behaving like this, and it looks like this, and it tells like this. It gives the information like this. So all this information, we can get it from these 4 steps. So the first business moment is measure of central tendency, where we do mean, median, and mode calculation. The measure of dispersion, where we calculate the variance in the data, standard deviation, which is required whether the data is normally distributed or not, and the skewness, where you'll be having a positive and negative skewness. That again gives you the probability distribution. So same different way, the fourth business moment decision, that is again having a different way of representation of data or analyzing the data, kurtosis, which again tells you more about probability distribution. And we have different graphical representation that gives you a graphs that makes you more clear with bar plot, box plot, scatter plot, line plot, histogram, and so on so forth. So all this will give you idea about what we are talking about, the data, which is in tabulated rows and columns, which we refer and call it as data frame. Now, after understanding and cleaning the data, we'll use appropriate specific model where there could be some constraints and requirements to be followed when we are talking about business understanding and data understanding. So this step will be helpful by the first 2 steps. So why first step? Even though they are not technically supporting, it is telling that what are the constraints that we need to take care before putting this model onto the data. So we can't use different models or different tools for different purpose. See, we always need to use appropriate tools for appropriate works. So generally, this modeling phase includes the model selection, the model training, the model specialization, and also keeping it a conscious depending on the application that we are working. So we should ensure that the modeling phase, the result of the modeling phase are reproducible by collecting the methods to follow to collect metadata. When I say a metadata, it is data about data. So sometimes we do refer a data that will be splitted for train, test, and validate. So we might use some of the hyperparameters. So when I say hyperparameters, these are the parameters that are randomly taken and adjusted. So when you are randomly choosing this hyperparameters, we will be getting changes with the accuracy. Hence, the model with the hyperparameter need to be executable in such a way that the model is optimized or it is meeting the objective. Hence, the model performance on different random parameters, that is hyperparameters, also helps in validating, also helps in testing, also helps in training the model. So when we consider the data, the fraud data, usually there are more challenges and the risk in the data. Why we are saying more challenges and risk is because the data is imbalanced. So when do you call data is balanced and data is imbalanced? Let's say example, we have yes or no option, true or false option. The other options here, yes option is 60% and no option is 40%. The true option is 80% and the false is 20%. So like this, you will be having a categories of data. We say that this is somewhat balanced and this is completely balanced and this is also balanced. But when I say 98 and 2% and 98%, do you think that it is balanced? You can also have a weighing machine. So when you weigh the particular items on the either side, so at least the amount that you are getting it should weigh the balance. If you are keeping 6 stones, you can either keep 5 stones and make it balance, or sometimes it will be towards 6 only, but not completely towards 6. So that means taking a decision and getting a insights of it will give you the accurate one. Let's say example, 98 transactions are legal and only 2% of transactions is illegal. So it is hard to segregate train data and test data and validate data. So the challenge here is when I consider this whole data 100%, if I make this as 80% and 20%, training as 80 and testing as 20, this 80% is from with the 98. If this 2% is included in this 20%, then the model which has been trained on this only legal, but it will throw you that I don't know about the other transaction. So the model should also say that the transaction is not identified and it has been unusual. Let's give you another example. A particular man is told to count the number of vehicles in the particular road, and the vehicle is car. The man needs to count only car. So the objective is to count only car. Let's say example, the road has with car, bus, truck, cycle, bike, auto, and many more. So the man is trained only to understand how car looks, what are the different types of cars, what are different companies of car, and also the dimension. So it has been told and the man has been trained to identify the car. Now, the road contains a bus. The man is trained only on car. So he'll not count this. Next time, the road is with car. So he'll identify and make it as count. And next time he has a bike. And next time he has an auto. And next time he has a car. So the car is counted. But he will be observing so many other unusual structure or the data apart from car. So what I mean to say is the model is also getting trained on the other things which you doesn't require. So we'll train a child and say this is dog, and whenever it sees cat, it will not say dog. If he's saying, then you're trained wrongly. So whenever it sees cat, the child will ask, it is not a dog, then what it is? So the child should be trained only on dog, can be questioned that this is not a dog, what it is. So whenever I give only the transaction, it also needs to get a transaction highlighted which is unusual, that it has not been aware of the other transactions. So the model training for the imbalanced data is more challenging. Hope you are getting it and you are understanding it. So as we proceed, the model selection, you need to evaluate the model. you need to evaluate the model. How do you evaluate? By using some accuracy measures and also error functions. I can say that the model will be accurate and also have some error. Putting together is one. So if I calculate the model is accurate for 95%, then I can say the error of the particular model is 5%. That is all known. You need not to calculate. So if I say you are getting a model with 4% of error rate, what is the accuracy that you are getting? Of course, it is 96%. But the process here we follow is the data what we splitted into training data, testing data, and validation data. So you train the data to get accuracy and you validate the data to achieve some accuracy. First time you train the data and it is predicting 50%. We can't consider this model as accurate. So we again train the model and it is predicting 80% of the model. Again we train the model. It is increasing to 90%. Again we need train the model. It is increasing to 93%. Again we train the model. It is 96%. Again we need train the model. It again go back to 95%. Again we train the model. It is 94%. So sometimes your model also goes back in predicting a lesser accuracy when we train more number of times. So we'll stop here and we fix the hyperparameters what we use to get this particular percentage. Now the model is ready with 96% of accuracy from 50%, and we have achieved some goal. And we have confident that 95% and above is good to be considered as a good model. So you build the model with some accuracy level and same with reference to the same data, you test on the data. And if it is also giving somewhere around 96% accuracy, then your model is accurate. It is working for all sorts of data. So it has been trained on the data. Now it has been tested and it is giving same. What if in case if it is a different? Let's say example 96% of data or accuracy is got from the training model and you are getting only 80% for the test case. So there is a lot of difference between that is 60% of the data, what we call it as error. So we use a regularization technique. We'll make it as standardized. We'll make it as normalized to get the trained with, we get the test data with some accuracy and it increases with the data. It increases with the accuracy. So this is what we refer. And when you are doing this training data and testing data, we come across overfitting, underfitting concepts. Now, when we have a huge difference between trained data accuracy and test data accuracy, we call that as a overfitting. Let's say example, we have gone to a shop and your waist size is 36. If the shopkeeper gives you 38, how it looks? It will be very loose and it is not fitting. It is not fitting. It is overfitted. So when it is increased, let's say example, he has given 37. So some percentage has been reduced and you can easily wear this. If it is 36, you don't have any overfit. It is fitted. Now, if I give 35, 34, 33, then it is underfit. Why? Because it is not fitting you already, because your waist is 36. So even if it is decreased, it is not matching. Even if it is increased, it is not matching. So whatever the target value that you have, you need to match with the actual value. So the target value that you got from the test data, the actual data is got from the trained data. So once your model is trained, you will be giving some values that is considered to be as actual. And after doing some test cases, you will be getting some values that is target. So these needs to be compared to tell that your model is accurately behaving and it is ready to accept any number of input. So you always need to have more data, not keeping with 10 columns, 100 columns or 100 rows. Less data will give you less variation. Less variation means less information. Less information means no deviation. No deviation means less accuracy. So all these are interlinked. Hence, the model evaluation is important step. After model evaluating, you need to deploy that in one of the platform, that is integrating into the existing software system. So in the life cycle, after evaluating the model, it needs to be deployed or into the pre-production environment. So the deployment is in the first phase of the machine learning development lifecycle, which depends on the training and prediction of the models. For example, when you are deploying a machine learning model, it is predicting the functionality and the model is used with the web service distributed system so that it will be suitably fitted. So whenever you are wrapping the model into the software architecture, it needs to predict and function the same. So deployment phases includes hardware inference of hardware definition, evaluation of production environment, that is testing, and user acceptance, and the plan for the model, and setting the deployment strategy. So there are different deployment steps to be followed when you are integrating with the hardware platform with the other software architecture. So this also plays an important role in deploying by using some of the tools. So once the deployment is done, the main risk is monitoring and maintaining the data, or monitoring and maintaining the performance of the machine learning data. So we can have unseen data which we haven't trained our model. So the model will not understand what it is, and the model will not predict suitably. Hence, it goes wrong. Hence, we need to evaluate continuously to decide whether the model needs to be retrained, which we call it as continued model evaluation, and also decide from monitoring, we need to update the model which reflects on the business use case, and it will be valuable for any model to be processed. When we say modeling and maintenance, it always refers to be validating when there is an unusual change in the model, or whenever there is a decrease in the performance of the model. Let's say example, we have trained the data to predict unusual data, unusual transaction, not rather than data, I'll say unusual transaction. So this unusual transaction will be predicted and will be informed. If this is not detected, there could be go down in the performance of the model. Then we understood that it is not predicting properly. There could be possibilities of unseen data. So the maintenance and monitoring is a part of machine learning quality assurance methodology, which is followed on any real world data that could affect the performance of the data. I'm talking about unseen data. So you need to regularly monitor the data, retrain the model to look after to the business use case, which takes a time to adjust, or it takes some quality work to look into the process of adjusting the models. So this is all about the CRISP MLQ, what we follow for any data science project, which gives you all the details how we need to proceed, how we need to do the data cleaning, preparation, processing, where exploratory data analysis is the important step to understand. Will later divide the data into train data, test data, validation data. And by selecting suitable model, we'll pass the train data and get some accuracy level. And we'll test on the same. After testing, it will be deployed onto the architecture. And after deploying, it needs to be monitored whenever there is a change in the real world data. And we are not sure about unevenness or unseen data that could affect the performance of the model. Hence, we maintain that. So this is a crisp MLQ that we follow for any data science project. So this is all about for today. And we will be understanding the important step which is under crisp MLQ, that is exploratory data analysis, in tomorrow's session. So hope you got an information about crisp MLQ that we follow for any data science project. We'll stop here and we'll continue in the next session tomorrow, and we'll understand exploratory data analysis by considering some use case. So hope it is clear. And we are winding up the session. Is there any questions? Okay, so we are ending the session. We'll meet tomorrow.